So, what have we done so far? I know we haven't, I apologize that we haven't gotten into science yet. This is the first official Science in the Bible lesson. But kind of what have we done in the first two lessons? Can I remember big points from the first two lessons?
How do you know what you believe is true?
There you go, right? So I wanted to give this foundation that, in everything we want to keep the Bible central, right? The Bible is our foundation, because as we get into a lot of this stuff, as you guys already know, the precedent for the age of the universe, origins of life and stuff like that come from places that aren't biblical, right? And so people take the evidence that's been given and they try to make a conclusion. But if you don't start from the Bible, then those conclusions often don't line up with the Bible, right? So you have this conflict, and you have to pick what you're starting from, right? And so a lot of times, Christians have been made fun of and slandered a lot because they start from the Bible, but it makes sense because the Bible says that we're going to be called foolish, right? So as we go through this stuff, we'll see that the Bible goes completely contradictory to the thought of the time about the origin of the universe. And so, but this is just where we start. If even one of these verses is not true, then we can't take any of it to be true, right? So we have to start from the Bible, and we'll see some of the contradictions of that as we start. Okay, so but last week, a month ago, right, we talked about two different kinds of science, right? What were those two different kinds of science? Without looking. Observational science, okay? So that's something that we can see, we can test, right? So we can set up an experiment, we have a starting point and an ending point, right? So we can have initial values and ending values, and then we can draw a conclusion from that. Cut it.
Hey, brother.
That piece of paper and pen for you. Papers here. There's so many to choose from. Okay, so observational science has a starting and an end point, right? So that means that we can actually draw a conclusion from an experiment, right? What's the other kind of science? Not Ellen. Historical science, okay? So that deals with the past, right? So there really isn't a starting point for that. We live in the present, and we can make observations about the present state of the universe and the present state of the earth and stuff like that. But we can't say, it started like this and it has come to this point, right? So as we'll see today that, there are some indications that in the universe, right, the universe is expanding. We can see that. We can see that it's expanding at a certain rate. So as we'll see, it, depending on where you start, if you're going to say start from a naturalistic point of view, then you can follow that expansion back to a single point, and then you can extrapolate back, how long it took to get to a single point. So that's kind of, in a nutshell, the Big Bang, and we'll get into that. So it just, historical science, though, cannot 100% be validated, right? So if you really press an astronomer, they'll agree with you that to some extent, origin of the universe is philosophical, right? So there's a lot of different theories, and none of them can be proven completely true, because we can't go back to the beginning of the universe, right? So we can't validate 100% whether or not something is true. So in the end, all of it really is belief. And that starts with where you start. Do you start from the Bible, or do you start from man and his own sense of reason, okay? So there are three possible answers as to how the universe came into existence, right? And so these are just simple logical conclusions that we can make. And so the first one is that the universe created itself, okay? So this is, we'll see that it's not really held by a lot of scientists today, and we'll see in a minute why. Because if the universe were to create itself, it would both have to exist and not exist at the same time. right? So if something is going to create something, that initial something has to exist in order to do the act of creation, right? But if you're actually creating the universe, then the universe doesn't exist in the first place, right? So this really comes down to a law of non-contradiction, right? So we talked about, I think in the first lesson, that you can't say, my shirt is blue and my shirt is not blue, right? One of those statements has to be true because they're in contrast to each other. So we can see right away that the universe cannot create itself, okay? Because it can't exist and not exist at the same time, okay? So that's the first option, but logically it just doesn't hold up. The second one is that the universe has always existed, okay? So this used to be the prevailing thought until they found the expansion of the universe. So they used to think that the universe existed for all time, right? There was no beginning and there will be no end to it. There's just different cycles. And so we're here during this cycle. There might have been cycles before us that had life and stuff like that, okay? But the problem with this is, have you ever heard of a perpetual motion machine? What's a perpetual motion machine?
One that never stops once it starts.
Never stop once it starts, right? So it's like a closed system, and you don't have to add any more energy to it in order for this machine to keep working, right? What's the problem with that?
Something had to start.
Okay, something hasn't started. Let's say it's already started though. What's the problem with that?
They don't actually exist.
They don't actually exist because once something's started and you have this motion, eventually you're going to lose some of that energy that you're using in the form of heat and unusable energy sources, right? So eventually that energy isn't going to be usable anymore. So, and this is kind of based in the second law of thermodynamics. Anybody? Science quiz. All night tonight is just a total science quiz. Second law, thermodynamics. There's only 4 of them.
Like, is it the transference of energy or something?
No. Hey, I really appreciate you trying though, because that's better than everyone else in here. Okay.
In motion.
Yeah, I mean that's in the name. So, hey, but props for trying again. So the second law of thermodynamics talks about entropy, right? So everything tends towards a state of disorder. So if you think about it in terms of energy, we have usable energy. Let's say, I'll use this example here in a minute too, but let's say you have gas in a car, right? That's usable energy. But then once you use up the gas, you've transferred that into kinetic energy that you've used and then heat that goes out into the atmosphere, right? And so that energy is now in a different form that we're not able to use, right? So, but this is a law that they found holds true, everywhere in the universe at this point, right? That's why it's a law, because it's never been disproven. But as time goes on, everything tends towards this state of disorder. So we have usable energy, and eventually that is going to go into forms that are not as usable, right? So we have this disorderly state. But the problem is, in order for a universe to be infinite, it would have to, and for us to be here right now and for there to still be fuel, there would have to be an outside source that gives fuel to an infinite universe. Because if you think about it, if you have this infinite universe that has always existed, right, but we see that there's this finite amount of energy, then one would think that sometime in the infinite past, all that energy would have been burned up already, right? So we'll talk about later, stars burn up hydrogen, right? They do nuclear fusion, and that creates the energy for the star. But there's still hydrogen in the universe, right? So if the universe had existed forever, you would think that all that hydrogen would be used up, so there wouldn't be any hydrogen left. But the fact that there's still hydrogen, there's still energy available, kind of tells us that there was a beginning to the universe, right? So that's kind of led to the thought now that there was a beginning to the universe, and that's pretty standard frame of thinking for scientists today. Okay, so there was an analogy that, that I read. So if you get a car, someone gives you a car and they say, this is yours, you know, you don't have to do anything for it, but you only get one tank of gas, right? And you can never fill it up again. So if you drive that car, you know, you drive it however long it lasts, but then you run out of gas, then there's no, like, you can't use that car anymore, right? So that's kind of the same idea, is that if the universe was infinite, it would use up all the fuel, and then there wouldn't be any fuel left for stars and for us, okay? So what's the last possible answer? Creation, absolutely. So the interesting thing is that secular scientists and Christian scientists are all, pretty much all agree on that, right? So logically we walk through that the first two options really don't make any sense. So everyone really agrees that the universe has been created. The big question is, what created it, right? So where did that first act come from that caused the creation of the universe, right? What's the first mover and stuff like that? So as we go through this, one thing that I want to reiterate that I talked about the first week was that, you know, the problem with people not believing Christianity is simply unbelief, right? It's not ignorance. And so hopefully I will be able to do a good job of not getting snarky in my comments and not being like, oh, well, why would anyone believe this, right? Because people do believe it. Smart people who have spent their whole lives studying this stuff believe this stuff, right, that we're going to talk about. And that's not, you know, you can't logic someone into believing in the Bible, you can't logic someone into believing in Christianity. So hopefully I'll do my best to not be kind of downplaying what people believe, but we just got to keep that in mind, that it's not something that we can just look at and then just logically find our way to creation. So what is the Big Bang, right? That's the big question. What do you guys think the Big Bang is?
So like all the gases went together, like mushed together and then exploded, and then like something came out of it.
Okay. Anyone else? Any other theories?
Pretty close to my understanding.
Okay.
Everything was together and some triggering events started the
Okay.
universe.
So that first point that we're talking about here is called a singularity. Look at that. That's a big long word, spelled correctly.
It's pretty good spelling.
Yeah, man. Okay, so that's that point that we're talking about, right? And so the interesting thing is that, I'm not really going to go into this, but I'll just give you this. So some people think that this has happened before, that the Big Bang expansion has happened before. And so over time, you know, the universe expands and then eventually it contracts back in on itself, right? And then it comes back to this singularity again, and then it happens again, it expands again. Okay, so I mean, that's just another theory. But this singularity right here is really almost impossible to think about, because it's a point of infinite smallness and infinite density. Okay, so it's so small that you can't even imagine how small it is, but then it's so dense because it has all the matter that we see in the universe in this little tiny dense point. That's what the singularity is. Okay, and so the weird thing about a lot of theories and Big Bang stuff is they can kind of mathematically have an account for what happens after the singularity. But the problem is, the closer and closer you get to this singularity, the mathematics end up not really working. Because whenever you have numbers in this area, they basically equal zero, right? Because you're infinitely small is zero, right? And infinitely, so infinitely small is zero. So if you have zero in your equation that you're trying to work from, your equation's going to equal zero, right? So the mathematics really don't work once you get back down to here. That's why there's no perfect theory, because they can't really account for the initial singularity, okay? So, but you have singularity and then you have expansion. So it's kind of a misnomer with the Big Bang theory, right? Because that kind of gives you this picture of an explosion, right? A Big Bang. But the problem with that is there really wasn't an explosion. So it's really just a fast expansion. I know, it's really disappointing, isn't it?
Yeah.
I mean, I'm just gonna crush your dreams tonight. I really am. Okay? So it just started expanding out extremely quickly from the origin, okay? And so, I should have disclaimed at the beginning, I meant to disclaim at the beginning, I am not an astronomer or an astrophysicist, okay? So this is not my area of expertise. So I don't really know absolutely everything. I'm trying to put together a bare bones. I mean, I sound like I do, right? I sound like I got this covered. So, but that being said, you know, just because it's not my area of expertise doesn't mean that I shouldn't look into it, right? Because God gave us these minds to think and to reason and to think about all these crazy things in His creation, right? So just because you're not a biologist or an astronomer or whatever doesn't mean that you can just ignore that, really, because it's kind of a disservice to what God's done, giving you a mind to be able to think through that stuff. So even though it's not really, you know, my area of expertise, it's still interesting to me, and I hope that I do it like a good service and not disservice. So as we're expanding, there's different particles. They were called matter and antimatter. So what happens is these particles start expanding, and then they end up hitting each other and colliding. So if you get matter colliding with antimatter, they cancel each other out, and there's no net whatever. So I don't really know like what happens to whatever after they collide. But the point is that the theory states that there was more matter than antimatter, right? That's why we're here, is because there was more matter than antimatter. So I'm just going to kind of, a lot of stuff happened here at the beginning. So I'm going to kind of blow this up. So like this whole line is going to happen pretty much right here. So we have matter and antimatter just floating around, and then here at 0.01 seconds, I know you can't really see that. We have neutrons and protons. So what the theory says is that these matter particles start coming together and forming larger particles. And that gives us these neutrons and protons. And so from there, you also have to remember that as this is expanding, it's very hot, right? So how does it go? Big Bang Theory. What does it say?
Bang.
Sing the song.
Verse was in a hot, dense state.
A hot, dense state, right? So it's infinite density and really infinite hotness, right? At this tiny point. And so as it starts expanding, the temperature starts to dissipate a little bit as it expands, but if it's still confined to a small area, then it's still going to be super, super hot. So the important thing with that, based on the theory, is that what else goes with neutrons and protons? Electrons, right? But if there's so much heat and so much energy, then these neutrons and protons aren't able to hang on to electrons. So they have not entered the equation yet. And so as we go along, then the electrons, once it gets to a low enough temperature, then the electrons can add on to the neutrons and protons and form elements. And so any guesses as to how long that takes in the theory? Just a guess. Anything.
4
Just 4.
billion years.
4 seconds.
17 minutes.
Man, you guys are so close.
Years. Okay.
400,000 years, and then we have,
Oh.
Average our two
I just forgot this couple zeros.
then we have electrons coming in the equation, okay? So if we have protons, neutrons, and electrons, then we can start to have elements, right? So the simplest element is, told you this is gonna be a quiz.
Hydrogen.
Hydrogen, right? So hydrogen can then form, and helium as well, right? Those elements can form, and that's what's actually fuel for stars, right? Because if you think about it, that's the first step if you're gonna start fusing atoms together, right? You start with the simplest atom, and then you can fuse that together and form heavier elements, right? So, and then, I didn't really think about exactly how to do this. So then over the next,
So they figured 400,000 years based on math that they admit doesn't work at that level.
well, no, so like, at the singularity, it doesn't work.
Okay, anything outside of that.
Right.
They
So
think they got it.
even 0.01
Okay.
seconds afterwards, they have math.
Anything
corresponding.
other than zero.
Exactly, right? So this is 0, and they just can't deal with that. So there is some mathematical stuff. I mean, we'll see that there are still some problems with it, and we'll get to those. But yeah, that's a good question. Okay, so over these next 100 million years, now that we have these light elements, right? Then as gravity starts to fluctuate, don't ask me how that happens, okay? Gravity starts to fluctuate, and then we have star formation. This is all red. We'll try a different color. How about green? Okay, so we have star formation. And so this is just, all these matter particles and all these different elements coming together based on gravity, and as these elements come together, that area, that star, becomes more dense, right? And then it attracts more and more elements from the surrounding environment, okay? And then once we have stars, then actually the planets come into existence, right? And so that's due to stardust kind of colliding and forming these big balls of rock, right? And so, let's try blue. How about blue? So from here, we can start to get planets, right? So have you ever heard, like, we're created from stardust, right? We're made of stardust, right? So that's where this comes from, is that, after you form stars, and then the surrounding junk ends up being a planet, and then we evolve out of it. See, there's my snarkiness coming right there. Anyways, that, in essence, is the Big Bang, okay? That is the long of the Big Bang, and there's much, much longer of the Big Bang, but that's the brief synopsis of it. So really the question is, like, what are the evidences of this? And I've already mentioned that it's known that the universe is expanding, right? We can observe that. No one's going to disagree that the universe is expanding. So the thought behind why this, I forgot to add, this is 13.8 billion years ago. Billion with a B, okay? So this is how they get this, is by measuring the rate at which the universe is expanding and then extrapolating backwards to this singularity.
Do you mean physically expanding, like getting larger, or expanding like?
Physically
like
expanding.
Getting, like,
Yeah.
taking up more area,
Physically expanding.
okay.
So the universe is actually getting bigger. And the interesting thing about that is that means there's something outside the universe.
Expanding into what?
Right. And so no one has any clue, right? Because how can anyone know, like, what's outside? So if you look at, there's this really famous picture of, like, the history of the universe, and they kind of have this circular picture of it, and it starts with the Big Bang over here, and then it kind of expands, and it's kind of a cone, and there's dark space on the outside that's just space, and nobody has any clue what it is. So it's really kind of weird to even think about that, right?
Is space a thing, or is space the absence of things?
So the universe is a thing, right? And it's not really, right, we think of it as a vacuum, right? But it's still, like, you can be within the universe.
Right.
But
So
you're
you
in-
should be able to be outside of it, theoretically.
Theoretically, right? I mean, we'll never know. I don't think there's any way that we'll ever know that.
Do they
You had something?
see space expanding at the same rate in every direction, which means that it does go back to a singular point?
Very interesting. So,
It's a sharp dude right
that
there.
is a short-
Good.
Damn, that's a good guy. So, the interesting thing about the rate of expansion is that it's not really constant. So, I don't really know how they figured out, okay, in the past, you know, it was this or whatever, right? So it's not this, like, it's called a constant. They've given the value, they call it Planck's constant, based on the guy who found it. But it's hard to nail it down, and so that's why, we'll get to this in a little bit, that's why the date has changed so much.
And then I think going back to what you said earlier is, or along the same lines, is energy will begin to lose its power or its
Yeah.
energy will lose its energy, but it'll slow down, so
Yeah.
then you would expect the universe to be expanding at a slower rate over time.
But nobody knows the force that caused it,
Yep.
right? And nobody knows the force that's keeping it going. So it's like, there's just, I agree with you, right? So you would think that, and that's kind of the idea behind this whole, it expands and contracts, right?
Okay.
Kind of like this elastic expansion, contraction, back to singularity, and then another expansion. So that kind of gives credence to that whole idea that if it expands, it has to, you know, crash back in on itself based on gravity and that kind of stuff. So, the expansion is the first observation that kind of gives us an idea that maybe, you know, this is what's going on. And then the other one is called the cosmic microwave background. You guys ever heard of that? No?
Is it the radio wave thing?
Uh-huh.
They did have this in school when I was.
Yeah. Do you remember anything about that?
I watched Cosmos.
Okay, I'm sure they talked about it. I didn't watch it. I watched part of an episode and I got really mad at Neil
Oh.
deGrasse Tyson, so I just couldn't stand it.
Okay.
Okay.
Enough to speak in.
So the cosmic microwave background is this, they had this satellite here on Earth that they poked around the universe, right? And they looked and tried to listen to what's going on in the universe. And they got this very low frequency microwaves that they received. And at first they thought it was pigeon poop on the satellite. And so they were like, oh, well, that's why we're getting this crazy reading, right? Because everywhere they looked, they had this reading. And so they were like, what's going on? And so they cleaned off the poop and they put it back up and they were like, it's still there. We can't get rid of it. And so they've sent out these satellites out into space. And they've actually mapped the whole space around us that we can see. So they just point this thing in every single direction and it gives us this heat map of the universe, basically. And so the interesting thing is that it's pretty constant. So wherever you look, overall the universe is pretty constantly the same temperature. And so if you care, it's like 2.78 degrees Kelvin or something, which is actually really cold if you think about it. So room temperature is 298 degrees Kelvin. And zero is absolute zero, the point at which atoms and nothing moves whatsoever. There's zero energy. That's why it's called absolute zero. So the universe overall is about 2.78 degrees Kelvin, which is pretty cold, but at the same time, like, there's pockets of heat, right? So like stars generate heat, that's why we can exist where we are right now. So, but that kind of gives scientists some idea that maybe You know, if everything started from a single point, that possibly as it expanded, it equilibrated really quickly, right? And then you have this similar temperature in the whole entire universe. So, but once again, it depends on where you start from, right? So if you say, oh, I see the Earth or the universe expanding, it probably started at a single point, right? And then you find this cosmic microwave background, and you try to say, oh, well, that's, you know, that is explained by what we have here, right? So, as with any scientist, you know, there's presuppositions and these kind of ideas that they have in their head of how they want everything to look, right? And so, a lot of these theories are trying to fit everything in, all the observations that we have, trying to fit them in to fit the model, right? Yeah.
So shouldn't they be able to just look for the hot spot and know that's where it started?
May not be hot.
It may, yeah, because as it expands, theoretically, everything should be the same temperature. Or if it's not at the beginning, and we'll talk about that in a little bit, but there's real no way, because as we look around, everything looks the same, right? There are pockets of heat and pockets of cold, but it's not really like, oh, there's the hot spot of the universe, right?
So there's not a concentrated point at all with everything.
Right. And we might not be able to see it, true, too, because who knows where we are in the universe, right? I think I read something else that you can develop a model of the universe where the Earth doesn't move and everything else moves, right? Because of, and nobody could disprove it because of relativity and I move relative to you, but you don't move and stuff like that. Relativity is like the hardest thing if you ever like read about it. If you've watched Inception.
No,
No,
Interstellar.
Interstellar.
Inception.
Everybody seen that?
I was gonna say, I'm still recovering.
No, Interstellar. That deals with like relativity and stuff, and it's read about relativity before you go see that. Otherwise, it won't make no sense. But it's really difficult concept to grasp and kind of understand. I really don't. I kind of barely understand it, but we'll talk about more about that in a little bit. Okay, so let's talk about some problems with the Big Bang Theory. Everybody got this?
Mhm.
The first problem is that you will find Christians that believe this, right? So there are Christians that believe in theistic evolution, right? So they kind of have this naturalistic view of how the universe started, how the earth started, right? And then from there, they kind of work in the biblical basis of it, right? But the Big Bang Theory says that the beginning of the universe was natural, right? But we read in Genesis that it says God created the heavens and the earth, right? So from there, we can already see that there is really a stark contrast between what we read in the Bible and what we're taught through the Big Bang Theory. Now, you know, people have tried to say, oh, well, God created, you know, he started the Big Bang, right? But that's not really what the Big Bang Theory says, right? It just says, you know, this started, there's no acknowledgement that, you know, God created that first singularity to expand, right? So there's no acknowledgement of God's involvement at all.
One was spontaneous, one was created by some creator.
Right. So that's really the first problem. Another one is that Big Bang Theory claims billions and millions of years, right? So we'll kind of hit this next time. This might be a two-timer as well. But we'll hit this when we start talking about the age of the earth is the next part, and we'll talk about the meaning of the word day in creation, right? And we'll kind of break down what exactly that means. It's pretty awesome. So, but needless to say, millions and billions of years don't really line up with what the Bible has to say, right? So from there we can already see some problems. Another one that we can see from the Big Bang Theory is it says that stars came into existence before Earth, right? So planets were actually formed from stars. But we read in Genesis, right? Let's read it. How about that? So if we read in Genesis 1:1, it says, "In the beginning, God created the heavens and the earth." So here, the first act of creation is earth, right? So we can already see it's completely opposite from what we see in the Big Bang Theory. The Big Bang Theory says stars came first, earth was born out of stardust. But here we see that God created the earth before there were stars in the heavens. And then we see in verse 14, which is on day 4, it says, "Then God said, let there be lights in the expanses of the heavens, to separate the day from the night, and let them be for signs and for seasons and for days and years." Okay? So there's a real problem with the timeline here that we see in the Bible as compared to what we see in the Big Bang Theory. Another problem is that the Big Bang Theory says that eventually the universe will equilibrate, right? So we have this kind of this uniform temperature in the universe, right? But it's not exactly the same all over the place, right? So the average temperature around is the same, but it's not, everything isn't exactly the same temperature. But the Big Bang Theory says that eventually that will happen, right? As stars die out, because they're burning all this fuel, eventually thermal equilibrium will happen and everything will be exactly the same temperature, which is called heat death, right? So that's what we're heading towards based on the Big Bang Theory. But what does the Bible say about it? How's everything going to end?
With a lot of heat, actually.
A lot of heat, God's judgment, right? We're still on the earth when God judges the earth, right? We're still here when the end times come, which is stark contrast to what we see here. So from there, we can already see some huge problems. One problem that is pretty much just like a mathematical problem that the Big Bang Theory has is this, it's called the horizon problem. So if we have, that's not in the middle, is it? There we go. So the universe is expanding very, very quickly. And you can say that it's expanding faster than light, but really that doesn't make, if you say that to like an astrophysicist, they'll say that doesn't really make any sense. But it actually kind of sort of does. So the cosmic microwave background says that everything is pretty close to equilibrium, right? But if we have this expansion and then there's these pockets of hot and cold, okay, so we'll say the red is a hot spot and the blue is a cold spot. So if everything expanded initially at the same rate that we see now, there's no way for these 2 points to equilibrate, okay? So this is what's called the horizon problem. Because of the rate of expansion, there's no way for the universe to equilibrate to the point that it is today, based on the current model. So what scientists do then is they change the model, right? They change the theory to fit the observation, okay? So what they've done then is they said that at the beginning, the expansion wasn't quite as fast. So the initial expansion happens and it's slower than the current expansion, which allows time for everything to kind of equilibrate pretty well then, and then expansion picks up and starts going faster, right? You're getting a little snarky over here.
That sounds good.
I know, right? So, but really that's what scientists have done now, is they've tried to put everything together and tried to, take this observation that, it couldn't equilibrate at the speed, so let's make it slower so that everything can work out. And this kind of gives rise to this idea that the Big Bang Theory changes all the time, right? So the Big Bang Theory that existed when it first came out is not the same one that we have today. And there's 50 to 100 different models of the Big Bang Theory. And then there's some models that aren't Big Bang Theory that you can't really disprove, right? Because we can't really say that it happened one way or the other. So just, and this kind of goes back to this idea of personal opinion and not allowing it to like be your moral guideline, right? So if we're trying to figure out like what is the ultimate authority, right? That's what we talked about the first lesson, is that how do we decide what's the ultimate authority? Some people use personal opinion, and that's kind of what the Big Bang Theory is. But the problem is that it's turned into public consensus now, right? Because multiple people have jumped on this, and now people are using that as ultimate truth because that's what everybody else believes, right? So just a timeline of the Big Bang Theory. In 1919, it was thought that the universe was infinite, right? So the first three things that we talked about, like different ways that the universe could have started. Up until 1919, the general thought was that the universe was infinite, no beginning, no end. And then Hubble's constant was introduced in 1929, so that's when he first kind of saw that the universe was expanding. And the original calculation for the age of the universe was 2 billion years. And it's kind of interesting to note, though, that people who are trying to date the Earth with different dating methods, and we'll get into that when we talk about the date of the Earth, they estimated the age of the Earth to be 3 billion years, which is 1 billion years more than the age of the universe, right? So we can see that there's kind of some problems here with different dating methods, and how do you really know what happened that far in the past, right? 1955, it was 6 billion years old. In 1965, it was 10 to 25 billion years old. There's a nice little plus minus in there, right? So there's a lot of error involved in it. In 1993, it was thought that the universe is 12 to 20 billion years old. And then in 2006, when they kind of nailed down Planck's constant and the rate of expansion of the universe, that's where we get this best guess that it's 13.8 billion years. Okay, so that's kind of the thought right now. I already talked about the expansion rate and how it's not quite constant and it's difficult to measure, and so like that's kind of what gives rise to this changing timeline and this changing date of the universe. And the interesting thing to note is that every time it changes, the astronomers are like, this is it, we got it, we finally figured out, the age of the universe, which is really what they say right now, until it gets disproven by someone else's theory, and then that'll be the age of the universe, right? So we see this kind of constantly changing based on new information, and it's kind of disconcerting, actually.
So do we know that we have found the edge of known space?
No.
Because
It's
there's
just
always
changed.
more space if you're in a dark room and you're going around with the light, it always continues to grow and grow and grow.
Yeah.
Because of our limit of being able to see and know what's out there, we will, and as our ability to see further and further grows, we may find that there's more out there.
Exactly.
Which then that just continues the growth of how long did it take to get to that point. from
Exactly.
expansion.
And so the way that they date the universe is they find the oldest star. Okay? And then from there, they kind of say, well, the universe can't be older than the oldest star, right? And so I didn't really go into like dating of stars and stuff because it's kind of really complicated. They look at brightness, but then brightness depends on distance, and then distance depends on brightness, and so it's really confusing. But that's how they do it, is they find the oldest star they can see, right? And then from there, they can kind of backtrack and figure that out. So right now, the Big Bang Theory is the thought of the day, and it will be until someone proves it wrong, right? Well, on February 9th of 2015, this year, okay, these two guys came out with a new theory on the universe. And their theories, they use quantum mechanics, and don't even ask me what that is, I have no idea. But they use quantum mechanics to kind of prove that the universe is infinite. So their theory is totally contrasting to the Big Bang Theory, right, and the general thought of today, but they used mathematical models to say, this is how it works. And so they got rid of the initial idea that there's a singularity, and from that they can use math to prove that the universe is infinite.
So there is nothing new under the sun.
Yeah, I was gonna say, wasn't this where we started?
Yeah, so, but even though, you know, logically we see that there's a problem with that, they've done math that says that that might possibly be it, right? So I've read that it's probably not gonna catch on, like there's still some problems with it, but at the same time, no one can disprove it, because we don't know. That's the end goal, or like, that's the takeaway, is that we just have no idea really what, you know, what happened in the past. So, this gives us a problem though for those Christians that have attached the Big Bang Theory to the Bible, right? Because we've seen that theories in the past have been disproven, right? We used to think that the earth was flat and stuff like that, right? And that's been disproven. The problem with attaching the truth of the Bible, the validity of the Bible, to a scientific theory or a scientific thought is that what happens when that thought gets disproven, right? So if you're a Christian and you base your creation story on the Big Bang Theory, and this theory that says that the universe is infinite ends up being true, right? Has better proof than the Big Bang Theory, what happens to your faith? What happens to what you believe about the Bible then? Because you based the truth of the Bible on a fallible theory. And so that's really one of the biggest problems with the Big Bang Theory and applying it to Christianity, is that then that gives it validity and gives it truth, even though that's not really what we read in the scriptures. So it undermines the authority of the scriptures to attach it to human theories that are based purely on reason and knowledge. How are we doing? 7:30? Okay. Just let me know when you guys want me to stop. We only have like 2 more things to go over that might take a while. Anyways, so I want to hit 2 things that are, the first one is a question, and it's about galaxies more than 6,000 light years away, right? So that's one of the big things that comes up for Christians from astronomers who are like, well, how can you believe the universe is 6,000 years old when we see galaxies that are, you know, millions of light years away, right? Stuff like that. So the question then becomes, how do we judge the distance of a star? Okay? Any guesses? Oh, we already have stuff like me. How would you measure the distance to a star? Somebody's got to have a guess.
How long it takes the light to get to us?
Okay.
Well, we don't.
But we
that's
don't
too
know where
far.
it started, right?
Distance from that star to something out there that we know. I don't know.
Okay.
I have trouble.
Good, that's a good answer, because that means that this is gonna matter.
I have trouble with just the idea that we can know something is that far away. If it's that far away, how do we see it? I don't get it.
Okay.
I don't get light years.
This is the sun, just in case. Here, I'll label it for you guys. Sun. What is this? Earth. Good. So we know the Earth rotates around the sun, right? Yeah, there's 2 Earths, because at one point in the year it's over here.
What is that?
And then another point is over here. Okay? So if we know that we can know the distance between the Earth and the sun, and so we know this distance and this distance, then we can know this whole distance between when we're on one side of the sun and the other side of the sun. Okay? And then if we see a star out here,
Trigonometry.
Exactly. So we can measure the angle to the star relative to the sun, right? And then 6 months later, we can measure the angle of the star relative to the sun. And based on angles, we can then know the distance to the star. Pretty cool, right? The problem is, what happens if this star is 1,000 light years away, or 100,000 light years away?
So is it a guess to the star?
What's that?
Is it a guess from the distance of the Earth to the star?
No. So you can calculate this, no problem, up to a certain time.
How do I know
Up to
that
a certain-
star's not moving?
I don't know.
Do they
Don't
not?
ask me- I tell you, don't ask me questions like that. I already told you that. This is prepared stuff right here, okay? Okay, so we can know the distance to stars up to about 400 light years. Because as this changes, like the distance, these angles are gonna change, right? But the further out you go, the less the angle changes relative to the distance, right? So at some point you get to a distance that out past that, the angle doesn't change enough for us to know exactly how far away it is, okay? So this doesn't work up to a certain point. So what they do is, they use known distances, so they look at stars that are close to us. So let's say this is 400 light years, right? That's at our limit, right? And then we can look at this one, 300 light years, and then we can look at this one, 200. And then what we can do is we can look at their brightness, and we can judge based on their brightness and how that varies. We can judge, like we can kind of get a ladder or a ruler of sorts, and then from that, that's how they kind of judge the distance to other stars that are outside. So it's kind of difficult because you don't have anything outside this 400 light year to measure it against. So you're using this short ruler and you're kind of stacking them on top of each other, which isn't really very precise, but at the same time, that's the best we got, right?
A lot of assumptions, it seems like.
Right. So there's a lot of variability, but the fact remains, and that's indisputable, is that there are stars and galaxies that are more than 6,000 light years away from Earth. So the real question is, what do we do with that, right? As Christians, how do we respond to that? And so one of the big things is this idea that light has this consistent speed. And so we think of light having, I can't remember exactly how fast it goes. Does anybody remember? I probably should know that, but yeah, me either. I don't know either.
1.87 miles a second.
Okay. You sounded so confident in that too. Okay, so but there are different theories that perhaps light doesn't have a constant speed,
I gotta know now.
right? And there's also this idea of time not being constant. What do you got? 1.8.
This is roughly closer to about 3 million meters per second.
Oh, 3.98 or something?
Well, this is telling me 299,792,458 meters per
Times
second.
10 to the 27 or 37?
671 million miles an hour.
That's pretty fast.
That's eating it right there.
That's pretty fast.
That boy is digging.
That's pretty fast. So, but there's also this idea of time, and that's kind of a relative thing, right? So if you watch Interstellar, man, I should have watched it before you came. It just would have made this so much easier. But it deals with this idea of relativity, how time is not constant everywhere in the universe. So if you send a spaceship away from Earth, you know, it might be gone for a year if it goes way out into space, but more than a year will have passed on Earth. And so it's weird.
Planet of the Apes.
Sure. Planet of the Apes. Yeah, that still isn't getting through to him.
Okay.
Okay?
Sorry.
I'm sorry.
That's okay.
I don't like science.
So, but there are theories that can explain it, right? And so one of the things that I always like to think about when it comes to this is that there are young Earth creationist astronomers that exist. They're real people, right? Who study this stuff. It's true. They study this stuff and they don't have a problem with 6,000-year-old creation, right? So you would think someone who studies their whole life, has a PhD in astronomy, right? If creation wasn't a viable option, all of them would just say Big Bang Theory, right? But the fact that they, get funding and they do their job and they can still believe in a 6,000-year-old universe gives credence to the fact that this is still a viable option when it comes to origins, right? So there's this guy, Dr. Jason Liesel, who made this theory, which is basically what astronomy is. But basically he says that light in any one direction can have infinite speed. And the interesting thing about that is you can't actually measure the speed of light in one direction based on relativity. So they've calculated the speed of light, but that's from one place back to itself. Because if you go from one place and then you synchronize watches and then you walk one watch further away from this watch, then they can't really be synchronized, and so it's impossible to calculate the speed of light in one direction. I know that makes no sense, but this theory is called, are you ready for this? Here, I'll write, should I write on the board? No, you should spell it.
Why would you do that?
It's called anisotropic synchrony convention.
Oh, you got that.
Take it syllable by syllable.
I already forgot it past name.
S-O-P-R-O-P-I-C.
Okay, that's the first word. Anisotropic.
Did I really spell that word?
Synchrony.
No,
Synchrony.
I'm out.
No, you gotta.
Next person do the next word.
Tag team.
I can't believe I spelled that word.
Anyways, that is the idea behind anisotropic synchrony convention, is that light in one direction can have infinite speed. If that were the case, then we can see how, light that we see hundreds of thousands of light years away can get to Earth, right, in 6,000 years. So, but there's no way to completely disprove that. There's no way to measure the speed of light in one direction. So there's just it's basically what this is, theories, right?
So the speed of light is the speed of it going out and coming back? you said?
Correct.
I
So
never knew that.
Yeah.
That freaks me
I
out.
know, it's weird, man. So, my response to this has been in the past that, well, God created the light on its way, right? So let's say that light has a constant speed, and it's coming from those stars, but, God created humans mature, why didn't he create the universe mature, right? With light already on its way. But the problem with that is we see stars dying that are more than 6,000 years away, right? So if that's the case, right, and light travels the same speed, what does that say about those stars that are beyond 6,000 years old? Did they ever exist? Right? So if the universe hasn't existed for or if it's only existed for 6,000 years, did those stars further than 6,000 years that we see dying and exploding, did they ever exist? Because that last light reaches us, and then we see nothing in that area of space. So that really is the problem with saying, well, God created the light on its way already, is because we see those stars explode. And if light travels the same speed, then that really means that God kind of lied, right? God kind of said, oh, look, there's a star over here. Psych, right? So, because God does that, right? He just says psych. He really doesn't, right? God does not lie. That's one of his characteristics. So we can take him at his word that if we see a star out in the universe die, it existed, right? We know that God created it, and God, ordained that it would die, and that we can see that happen here on Earth. So,
Why would light have to come from a star, though?
that's an interesting point, because Genesis 1 says he said, let there be light, but then the sun and moon and stars weren't created till later. So what was that original light?
It's not in my notes, so, you know,
Like, I mean, that could
I'm just
be-
not at liberty to discuss that.
Just
I have no idea.
Cause even if we saw the end of a light, that could just be.
But you
light.
can, it's characteristic light of a star exploding. So that there's different colors that stars go through as they explode and like they go supernova. So we know that the light comes from a star. So we know that it's a star and not something weird. Yeah, I don't know what that first light was. It was probably God, right? Because God is light. So he probably gave his light to something in the universe, but I
That's
don't
what
know
most
for
people
sure. Okay, and so that's kind of the answer to that question. And the point of that is to say that, you know, a lot of times as Christians, we get these questions that are like, well, how do you explain this? How do you explain this observation? But the important thing to think about is scientists sometimes can't really explain stuff either, right? And they get to say at the end of their papers, we don't really know, right? That happens all the time, right?
Theory.
Yeah, exactly.
Is it in a footnote though, it's not even like in the paper?
Yeah, so right, you know, at the end they say, we don't know, and then they say, well, maybe we do know, right? Because they have to give validity to what they say.
They need grant money.
Exactly, so they have to kind of know what they're talking about. But the point is that scientists are able to say, you know, we don't know. And the interesting thing is that as Christians who believe this crazy thing called the Bible, right? We're not really afforded that opportunity a lot of times. Is that we say, I don't know. You know, I don't know how to explain that. And then we get this ignorance label put on us, right? And just like,
Standard.
you know, well, you have to come up with a theory to explain this if you're gonna believe that crazy stuff that you believe, right? So I would just wanna caution you that that's not really logical, right? We shouldn't be able to just have all the answers, because we're humans and we're fallible and we don't really know everything, right? So it should be okay for us to say, I don't know. And that's not gonna sit well if you're gonna have a logical argument with somebody, but in the end, at some point, we just don't know. And it has to be okay for us to say that. So I want to encourage you with that, but it's probably going to get met with a lot of cynicism and nastiness. So that's all I got for tonight.